Welcome back to The Explainer. So today we're diving into something that is honestly a total game changer for how we think about software and really human collaboration as a whole. We're looking at the OMI object model, and specifically this incredible core philosophy: agreement is all you need. Look, if you've ever felt like digital collaboration is just, an endless, soul-crushing debate and a Slack channel where nothing actually gets built, well, OMI offers a completely different, highly structural way out of that mess. I want to start right out of the gate with a quote from the source material that just absolutely blew my mind. Disagreement is not failure. Disagreement is an unresolved file path. I mean, think about how completely that flips our normal view of conflict on its head. Usually, we see a disagreement as a roadblock, right? A social failure or just annoying adversarial noise. But OMI literally treats it as missing code. It's just an unfinished compiler error that's sitting there, waiting to be fixed. Okay, let's dive into this. Here's our roadmap for today. First, we'll redefine agreement, then look at disagreement as unresolved paths. After that, we'll explore the collaboration compiler, walk through how we go from intuition to structure, and wrap up with agreement as a protocol primitive. Let's get right to it.
Starting off with Section 1, redefining agreement. So to really wrap our heads around OMI, we have to kind of unlearn what agreement actually means in modern systems. In the OMI doctrine, agreement is not about social politeness. It's definitely not just passive consent, like everyone just nodding along. It is a literal act of construction. It's the precise moment when shared intelligence actually becomes an executable structure. Basically, two agents only truly agree when they can preserve each other's intelligence inside a shared structure without dumbing it down or just tossing it out.
And there is a really sharp contrast here with how things usually work. Standard AI, or collaborative systems, they tend to treat clashing ideas as adversarial noise. They answer a clash with ranking, outright refusal, or just endless debate. But the OMI system, it answers with construction. It actually routes incomplete ideas. If an idea can't be implemented right this second, it's not just thrown in the trash. The system just points out the missing part. It names the gap.
Which brings us to Section 2, disagreement as unresolved paths.
So what actually happens when we clash over an idea? Usually, it's a massive drain of energy. Passive critique just consumes energy. It focuses on policing language or shooting ideas down without offering any kind of path forward to build something. We have all suffered through those painful Zoom meetings, right? But constructive critique, at least in the OMI sense, actually generates structure. A conceptual objection is literally only useful if it reveals a missing boundary, a missing rule, or a missing closure. If it doesn't do one of those three things, OMI just considers it waste. Period. Moving on to Section 3, the collaboration compiler. Now, OMI isn't just an object model. You can really think of it as an agreement compiler. It takes informal, squishy, conversational alignment and actually lowers it into hard executable code. Let's walk through this 6-step lowering path. Step 1, an idea is received. Step 2, if there's friction, a boundary is named. Step 3, that boundary becomes a written rule. Step 4, a test is created to prove it. Step 5, a replay path is verified. And finally, Step 6, a visible state is rendered. And here's the kicker. If any stage is missing, agreement hasn't failed. That missing stage simply becomes your next build target. This totally eliminates that awful ambiguity of, wait, I thought we agreed on this, that derails so many projects. But hold on, don't mistake this focus on agreement for somehow bypassing the rules. OMI absolutely does not allow symbols or social consensus to authorize invalid state. Take a look at this 128-bit frame quadratic formula, Q frame of S equals 0. What this means is that agreement does not get to bypass strict mathematical validation. The carrier shell has to be absolutely lawful first. It must algebraically evaluate to 0 before any payload or agreement is even interpreted. Once that frame is validated, OMI asks a central, absolutely crucial question to any collaboration. What is your generator pointer? Think about that for a second. If collaborators agree on this brilliant new idea, but they can't identify the exact generator pointer for it, the agreement isn't executable yet. It's really just a mood. A vibe. This is what's known in OMI as the generator discipline. It prevents conceptual sprawl by making sure every single idea has one canonical principal pointer. It's kind of like a strict filing system. A vague agreement has to become a specific file path. Then that file path narrows down into a 128-bit address. That address acts as a principal pointer, which then generates a mathematically closed derivation region. Everything, and I mean everything, belongs to a specific addressable root.
All right, section 4, from intuition to structure. Let's make this concrete and see exactly how this compiler works in a real toy scenario from the source material. Imagine a collaborator throws out an intuition like, OMI should use base 36 symbols everywhere. Now, in a normal system, this is where the endless debate starts, but OMI preserves this idea. It just receives it as step 1 of compilation. Then, inevitably, a second collaborator jumps in with an objection. No, base 36 is a projection, it has no authority. To us humans, this looks like a classic argument. But OMI? OMI simply sees a missing boundary. It treats this disagreement as hard evidence that a closure is missing. So, how does the compiler step in and actually translate that conversational friction? It's brilliant. First, the disagreement gets an address. Then, the boundary becomes a rule. The system must project the base 36 orbit. The objection itself becomes a closure. It explicitly forbids base 36 as an execution authority. And finally, they write a test to validate that base 36 is used as visual metadata only. Boom, the conflict is completely resolved into an executable structure. And that brings us to our final section, agreement as protocol primitive. This completely rewrites the rules of distributed intelligence. Let's compare attention, which we hear about literally all the time in modern AI, against OMI's concept of agreement. Attention selects relevant context. It retrieves, it weights, it ranks data, right? But agreement? Agreement commits that context to structure. Agreement binds, preserves, routes, and creates replayable paths. So the crucial point here is attention is about focus, agreement is about construction. And importantly, that construction has to be visible. The collaboration loop in OMI ends in a visual projection, something called a voxel. And this voxel isn't just a pretty little graphic. It is cryptographic, visual proof that the agreement actually survived transfer, resolved its boundaries, and became real, replayable state. So, I want to challenge you on something. The next time you're collaborating with a team, or even an AI, and everyone is just nodding along, I want you to ask this exact rhetorical question out loud. If we agree, what is the generator? What is the exact boundary, rule, or test that proves this agreement is actually real and not just a passing mood? I'll wrap up this explainer with a final provocative thought, straight from the source text. We become more than we are alone because agreement allows intelligence to survive transfer. Seriously, when we stop treating disagreement as an attack and start treating it as an unresolved file path, we can finally start compiling our shared intelligence. So next time you hit friction with your team, ask yourself, are you going to start an argument or are you going to start building? Thanks so much for joining me on this deep dive into the OMI object model.